All right, so I'm going to do two things today. First, I'm going to do a quick demo of something that may or may not be important to you in the future if you ever try to access a set of DICOM files in Horos. This would be particularly important if you ever work like in the medical legal field and you're getting sets of DICOM files for various clients. I don't know that you'll remember this years from now, but maybe something will jog your memory and say, "Oh, Jim told us something about how to do this," and then you'll have to look it up again. All right, so I'm going to open up Horos, drag in two sets of studies here. One is just the mechanics data set, which is one of the standard OSIRIX data sets that I use quite frequently. Then another one is actually a set of DICOMs from a medical legal client that I worked on several years ago. So let's see here. I'm going to expand in here and see if I can remember which one I want to use. All right, I think this is the one I want to look at. So I'm going to look at the 2D viewer first, and then we see our images. So these are a series of, this is a CT study from the thorax. And we're looking specifically at the thoracic spine because this guy had a fracture of the thoracic spine. And now from here, I want to go to, sorry, I got all this Zoom stuff in my way. All right, I want to go to the 3D volume rendering. And we get this that pops up that you've probably not seen before. I use this data set specifically because I ran into this issue when I tried to access this particular patient's data to illustrate the fractures of his thoracic spine. So normally, DICOM files include all of the information about the spacing of the individual slices, because you remember that with a CT, you have a series of axial cross-sectional slices, and those slices are a certain distance apart from one another in a vertical direction. So that's the spacing, or what's called the interval. And the DICOM files normally contain that data built right into the file, so it knows automatically what that spacing is or what that interval is. For whatever reason, this particular set of data didn't include that. The DICOMs didn't have that information in there. So if you ever encounter something like this, you open a set of DICOMs and it brings up this dialog box asking for this slice interval. Now it seems to know the resolution in the X and Y directions, but what it's missing is this slice interval. And if I click OK and say that it has a 0 millimeter slice interval, it's just going to put all the slices together in a single plane. There's no spacing between. So I have to figure out what's the spacing between the individual slices. And there is a way to do that by actually looking directly at the films, the film images. So if you look here in the upper left corner of this particular image, you'll see there's a number up there, negative 30.63. And as I use my arrow keys and just cycle through these, the next one is negative 31.25, negative 31.88, negative 32.5, negative 33.13. What I realized when I started tabbing through these things was that the difference between each image in the series was either 0.62 millimeters or 0.63 millimeters. And what it turns out it's doing is it's rounding, right? So the actual spacing is 0.625 millimeters. Now, so I said, okay, the difference between, negative 33.13 and whatever the next one would be, negative 31.78, that's, a difference of 0.625 on average, right? It's like I said, it's either 0.62 or 0.63, but I could say it's rounding off from 0.625. So I went ahead and entered 0.625 as my slice interval. And it worked. I got a 3D model, 3D representation, 3D volume model of this guy's thorax and then his thoracic spine. But I started looking at the model that I had and then looking at the written records that I had and realized that everything was backwards. It said that he had fractures of the transverse processes on the left. I'm looking at the model and they're on the right. And there was some other detail that was on the left that I'm looking at the model and it's on the right. Everything was backwards. And so I came to a realization and then later looked up, in the there's not really a Horos manual, but you can find information online about it, that negative sign makes a difference. So the difference between a space interval or a slice interval of 0.625 versus negative 0.625, you wouldn't think it would matter, right? It's just a distance. Why would it matter if it's a negative distance or a positive distance? It's just a spacing, but it matters. If you don't include the proper sign, positive or negative, it literally creates a mirror image of the model. So I now know that for this particular data set, it's a slice interval of negative 0.625 millimeters. And so we get, this looks like just a chunk, but if I grab our tool here, we got a lot of other stuff in the way. There's a lot of, devices around here. Let me grab my scissors and get rid of all this stuff in the front. And then rotate it around and you realize we get a pretty good representation of this person's chest. And then I could gradually hide the skin and everything. And of course, I'd want to remove those objects behind his back if I want to look at the thoracic spine. And I don't know if we'll actually be able to see his injury very well. Whoops. Oh, yeah. It is right. Helps that I read the record so I know where to look, but it's right here. This is T5. And I don't know if you can tell, but there's a line going across T5 that shouldn't be there. That's actually a fracture that goes clear across both transverse processes and both lamina at the T5 level. And if I like removed his heart or got rid of some of the anterior stuff and looked in here, we'd see that there's also a fracture of the vertebral body at that same vertebral level. But so the point of all of this is just that if you ever do try to open a set of DICOMs and it brings up that dialog box where it just has a blank slice interval, you can determine that by looking at the spacing of the slices as listed, right on the two-dimensional images. And remember to keep track of whether it's a positive or a negative number there, because it makes a difference. All right. The other thing I want to do today, the main thing I want to do today, and what your exercise is all about today, is segmentation. And somebody shout out to me, Mike, did I hear correctly that you may have done a little bit of this with Glenn using Slicer? Okay. So you know the basic idea of what we're doing here. We are isolating a single object, a single anatomic structure from a data set, and then ultimately exporting a 3D model of just that one structure separate from all of the other structures. And I've played around a little bit with that in Slicer, but I know a lot more about it here in Horos. So I'm going to open up this particular data set. It's Mannix data set, and I'm using this angio aorta. It's a CTA, so a CT angiography. And look at go to my 2D viewer. And I do all of the segmentation in the 2D viewer because it involves actually identifying and isolating a structure on each individual 2D slice. And then I'll show you the trick for then separating that from all of the surrounding structures and exporting it as a model. Horos has three different ways of doing segmentation. I'm going to start with the hard way, and then I'm going to show you an easier way, and then I'm going to show you an even easier way. But it's helpful to know all three of them because sometimes you can use the three of them together in combination to really capture some complex, difficult structures that may be difficult to segment any other way. So the first way of doing segmentation in Horos is up here in the menu, and because now my, can I hide this thing? Yeah, right. Up here in Horos, there's a little button here. It looks like just like I don't know, a little green capital letter I turned on its side. I think that's supposed to be like a measurement tool, yeah, for measuring length. But there are several tools, like the brush tool and some polygon tools, that let you basically draw on one of the two-dimensional slices and define something that's known as a region of interest. That's how Horos refers to segmentation. It's like you're defining a region of interest to extract a model. So I'm going to show you the brush method first. I'm going to zoom in. So you can still use the magnifying glass tool. You can still use this little hand tool, to move around. What I'm going to try to do is paint one of the thoracic vertebrae. And the tricky thing about doing this is, you know how the vertebrae overlap one another? Sometimes it's hard to know what's part of one vertebra and what's part of the one right above and the one right below it. So we're going to try to figure this out. Sometimes it's helpful to start here where we can actually see the body, the pedicles, and these would be the facet joints back here. So I know that's all part of one vertebra. Then I can kind of go up and down from there. So I'm going to use this brush tool, and I've done this before. You can change the size of the brush tool. It's like in pixels, I think. I've had pretty good luck with setting it on 3. You still get this really pixelated edge, and it's going to export a pretty ugly image because it's going to still be pixelated. But basically what I'm going to do is I'm just going to paint I'm going to fill in this entire vertebra on every single slice where it appears. So it's kind of tedious and time consuming. And I won't lie, the results are mediocre at best, but what you can do is then export to, your favorite 3D program and then clean it up over there. Whoops, didn't mean to do that. I'm going to be sloppy in the interest of time. Now, do you notice that it's like there's 2 different things here that are kind of overlapping one another? The one that's active right now that I'm painting with right now has this black outline around it. It's actually just created like 3 different regions of interest. And if I tried to export just one of these, it would only get like the area that I'm coloring in black right now. It's not going to get the other one. And it's also not going to, it's only going to get the region of interest that I painted on one image. One of the tricks that you have to use is even if you make like 27 different regions of interest, it doesn't matter, because what you can do is you can tell Horos to select all of the regions of interest in the same study, in the same data set. So if I click up here in this empty space, it's actually going to start creating a different region of interest. But again, it doesn't matter because eventually what I'm going to do is just tell Horos to select all of them. All right, and I realize now that my transverse process is sticking out from the side near the lamina and the pedicle. I think I had seen part of that transverse process in the previous slices, but it was disconnected, so I wasn't sure if that was part of the transverse process of this vertebra or a different one. So I'm going to go back to those previous couple of slices and add that little bit of the transverse process that I saw before. I bet you that's part of one over there too. So yeah, there's a little tip of it. I might need to make this brush a little bit smaller just to get a little bit more detail. But again, I'm doing this fairly quickly in the interest of time. So I'm using a little bit bigger brush. Right, so I know this is probably part of that same vertebra. I'm just going to go back and forth. I'm going to go up and down in the section to figure out everything that's part of this same vertebra. Yeah. Yeah, like if you look, I'll show you in a second. If you look in the little floating palette that's to my right, this little guy over here, brush tool thing, you can switch to erase mode and erase from there, and then you can switch back to draw mode. And I know this is also part of that same vertebra. This is part of one of the facets, but it's not quite connected. Like we're just above or below the pedicle. So the facet joints continue above and below the pedicle, but the pedicle itself is still present on the left side of the body, which is the right side of the image. But we've gone either above or below the pedicle on the other side. So now I'm continuing to go up a little higher. Right, so now both facet joints are separate from the body. There's some of the body now that it's starting to get dark in the middle. That's probably part of the intervertebral disc. I'm going to go ahead and fill in only the parts that are pure white. Because I think what's happening is we're just starting to transition into the next vertebra. So we're in, right? So all that dark area in there is actually part of the disc. So this is the only part of the actual body that's still here. A little bit back here as well. But we still have those facet joints. Going, or a little bit more vertebra here, a little bit more of the body. There may be a little up there. I'm just going to leave that. And facet joints. Last little bit of vertebral body. Teeny bit there. But still more facet joints. You see some white starting to show up here for the vertebral body, but that's the body of a different vertebra. So I just need to finish up this tiny little bit of these facets. Now then I got to go the other way because I know I missed some the other direction. So if I go down this way, okay. So this one I got to paint the whole body in. And you can see just how horrible, sloppy job I'm doing, just again, in the interest of time. It's still taking way too long, but hopefully we'll get reasonably good results from this. See that transverse process on that side is connected to the pedicle. Here's the little bit of transverse process on the other side. Next, slice. Both transverse processes are now connected. Again, it's created a couple of different overlapping regions of interest there, but it's not that big a deal. I'm going to reduce my size here a little bit just so I can get this last little bit of that transverse process real thin. Oops. I jumped ahead. Oop, where'd I go? I accidentally clicked on the little bar at the top here. Boop, there we go. And jumped to a completely different vertebra. All right, so now we're back where I'm supposed to be. Once you've taken the time to create one of these regions of interest, I'll show you in a second if I remember that you can actually export them. And then that looks like the spinous process. So there's the rest of the lamina, the spinous process that belongs to this vertebra. So let me see. I think there was part of it back here. Yeah, you can export these. And then come back to them later. You can export them and then import them. Oops. Oh, this won't take too much longer. Yeah, maybe I won't completely finish the vertebra just in the interest of time. Hopefully you get the basic idea. let me just end there. Um, so to do anything with our regions of interest, we're going to use this ROI menu. There's a whole bunch of commands up here that are going to be important to us. So under here, here's where you could import regions of interest if you've exported them. Let's see, where'd they put the export option? Oh yeah, so you can save all regions of interest in this series. So it brings up a dialog box where you just give it a name and put it wherever you want. I'll just do that. I'll put it on the desktop. We'll save it using its name. So then if I ever wanted to import that, I just come up here and import, and again, find that same file and bring it in. You'd have to have the correct data set open. You'd have to have the mechanics data set open, but then you can import the region of interest into that. What I want to do is I'm going to select all regions of interest in this series. So earlier I was showing you that sometimes if I didn't click right on the right spot, instead of adding to the existing region of interest, it was actually making a new one. And actually, every time I went to a different slice in the CT image, it was creating a brand new region of interest every single time. So there's a whole bunch of them in here, but it doesn't matter. I've just selected them all. And then I'm going to go all the way down here near the bottom, and we're going to use this in all three methods. We're going to say set pixel values to. So I'm going to say apply this to all regions of interest, all of those ROIs that I created, even though I may have created dozens of them, doesn't matter. It's going to apply this to all of them. I want to say set pixels that are inside all of those regions of interest. So all of the pink areas that I painted, all of the pixels that lie within those pink painted areas, I want to set them to this new value. And I'm going to say set them to 3071. That is Horos's code for white. Doesn't follow normal RGB numbering system. Who knows? I have no idea still what this 3071 even means. I just know it means white in Horos. So again, what I'm saying is apply this to all regions of interest, every place that I painted pink on all of the different slices. Set the pixels that fall inside those regions of interest, inside the pink painted areas, set them to this new value of 3071, which is going to be white. And hopefully if this works right, when I click OK, you'll see that the inside of every single area. Now, here's where I have multiple overlapping regions of interest, but it doesn't matter. The fact that it looks sort of uniform pink back there means that the image in the background has turned pure white. Now I'm going to go back there again and say set pixel values to. Again, I'm going to apply this to all regions of interest. But now I'm going to select all of the pixels that are outside of the regions of interest, all the pixels that are outside the pink painted areas. And I'm going to set them to a different value of negative 3071, which is Horos's name for black. And hopefully, all goes well. It's weird. It turned everything outside black, but it also turned some of the ones inside black. So let me go back here and reset the inside values. All regions of interest inside set to 3071, which is white. Okay. I don't know why it did that, but so now all of the pixels inside my regions of interest are pure white. Everything outside is pure black. So now we have very high contrast. we have white pixels, and we have black pixels. So we can create a surface model. So I'm going to go to my 3D tool here, go to 3D surface rendering. I may not have pointed this out before. I think I forgot to point this out. You can change the resolution of these surface models, which might actually give you better quality models. And I'm going to create just one surface, and I'm going to use the predefined value for bone. Because when you use the predefined value for bone, what it's looking for is a contrast between bright white pixels and everything else. Now, in this case, we have a really high contrast. We got bright white, we got solid black. But what this will do is it'll create a surface for that little chunk of vertebra that I created. And you'll be able to tell in a second that I obviously didn't get the whole thing. I probably got less than half of it, but that is the top of a thoracic vertebra. So we have the top part of the vertebral body. We've got the superior facets, the superior articulating processes. We've got part of the transverse process. We've got some of the lamina in the middle there, and we got the spinous process. So if I had gone through and actually finished this, took the time to finish it, I'd get a, reasonable model of a thoracic vertebra. It's very rough. I mean, you can see it's got all these crazy rough edges, but it does have the basic shape that I'm looking for. So I could use that as a reference. I could bring that into my favorite 3D software and either smooth it out, in Maya or Cinema 4D, or just use it as sort of a template and build something over it. But it'd be a pretty good guide. So to get this thing actually out as a 3D model, we're going to go up to there's a export tool up here, and my zoom thing's in the way again. Export 3D SR, that means export 3D surface rendering. You could actually export this directly as a wavefront OBJ file, which you could bring into Maya. I'm going to export it as an STL. This is the stereolithography format. That's the standard format used in 3D printing. It's also a good, handy format for converting, from one piece of software to another, because almost any 3D software will open it. So I'm going to call this mechanics vertebra, and it should automatically give it the STL file name or file ending. All right, so I just exported like half of a thoracic vertebra. All right, I'm going to now show you the second way of creating a region of interest or a segmentation in Horos. It's pretty important at this point that I get rid of all of these regions of interest that I just created. Because if I don't get rid of them, if I try to set the pixels inside to white and set the pixels outside to black, it's going to remember all these other regions of interest I created, especially because I'm going to continue to work in the same mechanics data set. So when you're doing this, just to practice, I'm going to say, delete all regions of interest in this series. And so all those little pink painted things go away. Now my pixels are still solid black and solid white, but as soon as I close this and go back to the original data set, they'll all come back. It didn't permanently change those pixels. All right, so I'm going to show you the second way, which uses polygons. Kind of like Bezier curves, which is what Illustrator uses, like paths in Illustrator, although it doesn't work the same as the Illustrator pen tool. It's got its own kind of weird way of creating curves, which took me a little getting used to because I've been using Illustrator for over 30 years. And so this was just came out in 1988. Yes. I started using it in 1990. Yeah, and the thing I've always found surprising, and I know I'm getting off on a complete tangent here, but Illustrator actually predates Photoshop. Yeah. You'd think Photoshop would be the easier thing to create, right? You're painting with pixels. But believe it or not, that vector thing actually predated Photoshop by a couple of years. All right, so I'm going to use the same data set. I'm going to use mechanics, angio, aorta, 1.5 millimeter. Go back to my 2D viewer. And I had used the magnifying glass to zoom in. I can zoom back out. Come on. Where are you not? Why are you not zooming? Huh. That's weird. Well, I can use the up and down arrow keys on the keyboard to zoom in and out, but usually these, yeah, that's different. Let me try that again. Huh. Wonder why it keeps doing that. Viewer. There we go. Right under 2D viewer, there's something to reset image view so I can get back here. All right, let's see. What are we gonna draw next? And I've already scoped this out, so I know exactly what I'm gonna draw next. I'm gonna draw a kidney because this data set actually includes the upper part of the abdomen, so it's got both kidneys in it. So I'm gonna go along until I start to see, here's a kidney. This would be the left kidney because we got the liver over on the other side, so that's left kidney. All right, so I've seen roughly where it is, and it's again my magnifying glass won't work, so none of these tools are behaving. All right, well, I can use the up arrow to zoom in. It's odd, though. I don't know why the magnifying glass isn't working. And that still doesn't work either. Very weird. All right, I'm going to use, let's see, I got to go back to the very first slice where I started to see the very top of that kidney. It's like, there's this little faint spot down here. That's the spleen at the bottom right of the image. And we're just starting to see a little tiny blotch of kidney show up. All right, so I'm going to use another one of the tools up here in the ROI menu. I'm going to use the closed polygon tool. And the way this works is you click, but you don't. Okay, that's perfect. Why the heck is that not? Now that's not working either. None of my tools are working. I'm going to go ahead and quit Horos and see if by some chance relaunching it is going to fix that, because that doesn't make any sense. All right, let's try this again. Okay, now everything seems to be behaving. All right, let's go back to where that kidney first started to appear. So we're going down through the lungs. The diaphragm, liver, spleen, and there's our kidney just starting to appear. All right, so this seems to work now. All right, so I'm going to get my closed polygon tool, and you just click and make a series of dots. You don't, so it's not like Illustrator. You're not clicking and dragging and creating handlebars or those control bars. You just click and go around, but then it smooths it out and gives you an actual curve. And something I discovered with this closed polygon tool, you don't even have to go back and click on the starting point. In fact, if you do click on the starting point, it gives you this really weird kink in the line. In fact, let me show you what that looks like. I'm going to click here on the starting point and it creates a closed polygon. But now I'm going to go to my next slice and then come back to that. And you see how it's all of a sudden just mysteriously distorted that point? I'm just going to delete that and try again. So don't even click back on the starting point. You can get close, but just leave it open and it will automatically close it. And if I come back to it, see, it's closed and it didn't kink the line. It's a very strange behavior. One of the nice things about this closed polygon option is that you don't have to do this on every single slice. You can skip 4 or 5 slices. And I'll show you in a few minutes that the software will actually interpolate between the slices. 1, 2, 3, 4, 5. And fill in the missing slices on every other level. 1, 2, 3, 4, 5. I don't even think you have to necessarily skip a consistent number of slices. I don't know that it matters, but I figured, I'm just going to go ahead and do that anyway. At this point, the kidney just looks like a big old oval, sort of an egg shape, but eventually it's going to have a hilum. And we're going to actually draw, we're going to use our polygon tool to draw, the indentation in the kidney where that hilum is. Still haven't quite seen it yet. I think we might be just about starting to see, whoops. Just about starting to see where that hilum is going to show up. It's going to be kind of anterior medial portion. Yeah, there it is right there. So it's this little indent starting to form right there. So there's a structure here that's actually visible in the hilum. That's either the renal artery or the renal vein. I can't really tell which, but I'm actually going to now go deep down into this indent. Same thing in this next several. It's a little hard to tell what's going on here. I'm just going to kind of wing it and make it up. I know that there's going to be that deep indentation where the renal artery and renal vein are located. Sometimes you screw up and you make one that's just really kind of way off. There's actually an arrow tool up here that lets you select these points and move them. So I really didn't like where that one particular point was. So then I'm going to go back to my closed polygon tool. And this is all renal artery, renal vein, um, renal pelvis. Eventually, once we get beyond where the hilum is, it'll just go back to being just a simple oval shape. So when we export this as a model, we'll get, your sort of classic kidney bean shaped kidney with a very prominent indent on one side. Being a little sloppy inside the pelvis because we won't really see much in there. We'll just see that there's a deep indent. It doesn't have to be that precise. Matter of fact, I think at this point it's just about starting to close up. So I'll leave a little bit of an indent. So here it's basically closed. Little indentation, but not nearly as deep. Do that. Just move the whole thing by accident. Finally starting to get a little bit smaller since we're getting towards the other end of the kidney. Still just a little bit of an indent here where the hilum was. I guess basically that's done. All right, so one extra step that we have to do now. And so we've got these polygon regions of interest. I could go back and edit them if I wanted. I could go back through all of them and move points around with the arrow tool. I'm not going to take the time to do that. But one important thing that we need to do here is we need to go to ROI, rename. So similar to what I did earlier, when I was using the paintbrush to create regions of interest, I was creating many, many different regions of interest. Well, every single one of these polygons is also its own region of interest. But what I'm going to do in this dialog box is I'm going to say, take all of those regions of interest that we just created, all of those closed polygons, rename them all as something new. I'm going to just call them all kidney. And then it will treat them all as if they are the same. So I'm going to say rename all regions of interest in this image, and I'm going to call them kidney, and click OK. So now if I were to look at any one of these individual slices, there's a little dialog box that pops up down here. Sometimes it has the name on it. Sometimes it'll actually say kidney. I guess it didn't do that, but they are all renamed kidney. So I said, rename them all as kidney, and then I need to find ROI volume. They moved it. There it is. ROI volume. Generate missing ROIs. So what that's going to do is it's going to fill in new polygons on every single slice in between the ones that I created. So we should be able to go now and look, there's a polygon on every single slice now. And sometimes Horos does a good job of generating the missing polygons, sometimes not so much. So if you think that it's created an ugly one, you can just grab the arrow tool and move some of the points around a little bit if you want to just make little subtle changes. Like this one's a little wonky, so I might move a few of these points around. So you can edit these as much as you want. I'm curious to see when we get into the area where the here's where the hilum is starting to appear. That's where it's really likely to kind of screw things up a little bit, not do such a great job. So you might want to adjust some of these polygons. Oops. But again, I don't want to take the time to do all of that. So now I'm going to do the same thing that I did earlier. I'm going to select all regions of interest in this series. So they're all selected. I'm going to go down to my set pixel values. I'm going to apply this to all regions of interest. I'm going to set the pixels. I'm going to do the outside ones first because we had a weird issue that happened before when I set the inside ones white first. I'm going to set all pixels that are outside the regions of interest to negative 3071, which is black. So everything outside all those polygons is now black. And then set pixel values to, again, apply to all regions of interest. All pixels that lie inside the regions of interest, set them to positive 3071, which is white. And so now we've got solid white, solid black. We can create our 3D surface rendering. Choose bone as our predefined value. And, oh, that's interesting. It didn't get rid of my vertebra. Because I swear I had said delete all regions of interest. But let's just take a look at the kidney and kind of ignore the vertebra for now. So there's our roughly kidney-shaped kidney with nice deep hilum on one side. Now, there's something creating a couple of really deep grooves in my kidney. Probably when it generated missing regions of interest, it just made one that was really funky. I just have to go back and tweak that and figure out why it kept my vertebrae. But all right, we will go ahead and export this to an STL. We're going to call this mechanics kidney. And I'm going to try this again. Let's say select all regions of interest, delete all regions of interest in this series. I don't know. All right, so let me show you the last approach. Let me just hide this. All right, I'm going to use that same data set once again. Go to 2D viewer. This time I'm going to make extra sure. Okay, it doesn't even give me the option to delete all regions of interest, so we're crossing my fingers that they are actually deleted for real this time. So this final method of defining a region of interest and doing segmentation in Horos is incredibly fast and easy and creates really good results, but it has downsides. It only works really well when you have a structure which has a very high contrast or very, that's very easily differentiated from the other tissues around it. So it would probably work reasonably well on a bone, maybe, especially if that bone was completely separated from other bones. I think if I tried to use this on the vertebrae, it would select like all of the vertebrae together and give me the whole vertebral column because they touch, they overlap. The one thing that I found this is really useful for is the lungs, because the lungs are solid black and they are very, very distinct from everything around them. And, the lungs are continuous structure. Each lung is a continuous thing, and they're actually connected to one another also because of the trachea, the bronchi, which are also black. So the way this works is under regions of interest, almost all the way down to the bottom is an option that says grow region, 2D, 3D segmentation. I choose that, it brings up this little dialog box, and I'm going to slide that over to the side. And I want to change this so it says we're going to create a 3D growing region using the entire series. What that means is I'm going to select an object which is, three-dimensional and where every part of it is sort of continuous, throughout all of our cross-sectional slices. So like I say, it works really well on the lungs because that's like, a couple of large solid structures that are black all the way through the entire series. I honestly haven't really tried it with a lot of other tissues to see how well it might work for something else. So I've set it to 3D growing region entire series. I want to make sure that the algorithm is set to threshold interval, which it normally is by default, but just double check that. And then I'm simply going to click anywhere in the image with the cursor, whatever structure it is that I want to try to, define and model. I'm going to click here in the lung, just anywhere in the black area. And notice that it kind of turned it green, although it's left an awful lot of black spaces inside. It also didn't translate over to the other lung, but there's this setting here called interval, which by default is set to 100. And there's a little slider over here at the right that lets you adjust that. And theoretically, it lets you adjust that. There we go. If I set that interval to a higher number, notice that it fills in more of the lung area and kind of eliminates a lot of the gray, which would be, bronchi and pulmonary arteries and things. It's also filled in the trachea. which in this case, happens to be round, and it's extended that over to the other lung. So, I don't know exactly what number to set here. I have a feeling I can also set it too high. Like if I click way up there, I mean, it's still, the green is limited to just the lungs and the trachea. So seems like it's hard to set it too high again because the lungs are so black. They're so distinct from everything around them. So then down at the very bottom of this same dialog box is a button that says compute. And I think everything else I just leave. Yeah, I just want to leave everything as it is. Click compute. And it turns red, but more importantly, what the compute button does is it then extends that same region of interest to every single slice. And if I toggle back and forth with my arrow keys, whoops, all right. Once again, I went too far. Get back up in the thorax. Yeah, see, even this is like the very inferior most part of the lung. This is kind of down like where the costodiaphragmatic recess would be, just above the liver and just above the spleen. But now if I just use my left arrow and go progressively higher and higher up inside the lung, you can see that it's done a really, really good job of defining the edges of the lungs. Now, this particular, this kind of oval indent over on the right side of the image, it's actually the bottom of the left lung. That's actually just where the dome of the diaphragm arches up into the lung. And even this little oval gap here, that's just, again, because of the dome of the diaphragm. This particular person actually has a tumor of their right lung, which you can see over here on the left. So there's this noticeable gap in the lung over here. I'm just going to leave that and we'll just export that as part of the model, but it's going to create like a noticeable chunk missing out of our 3D model. If I really wanted to fix that and I wanted like a nice perfect set of lungs, I'd have to grab my paintbrush tools and go in and paint another region of interest on every single slice where that tumor appears. But I'm not going to worry about it for now. And once we get a little higher up, the tumor disappears and then we get a nice smooth lung surface again higher up. All right, so we've created our 3D growing region here. I'm going to do exactly the same thing that I've done previously, where I'm going to change the pixel values. I'm going to select all ROIs, although there should only be one. Set our outside ROIs, or our pixels outside the ROIs, to negative 3071 for black. And then go back to all ROIs inside, set pixels inside the ROIs to positive 3071, which is white. So then we just confirm that on every slice. And create a 3D surface rendering. Once again, using CT bone as our predefined value. So it finds that boundary between the pure white and the pure black pixels. Might take a second. All right, there it is. Now, unfortunately, the tops of the lungs are cut off just because this particular CT study didn't include the very top of the lung, but it's got most of it. So you can see it's really done a nice job of capturing the indentations from the ribs. We look up at it from below. You'll see how the diaphragm bulges up into the base of the lung. You can actually see the trachea and the bronchi up there. And over here, here's where that indent is, that divot created by the tumor. But so, and look at the level of detail inside as well. So it's not just the surface of the lung. It's actually done a nice job of capturing the branching of all of the bronchi inside the lungs as well. So I'm going to export this as an STL file. That takes just a second longer to save because it's a bigger file. Close that. Close my 2D viewer. And I'm actually going to go ahead and quit out of Horos at this point. So this file right here, this is actually one of the regions of interest that I had exported early on just to demonstrate how you can export regions of interest. I'm just going to go ahead and trash that. But I now have 3 STL files on my desktop. I got the vertebra that I created using the paintbrush tool, the kidney created using the closed polygon tool, and my lungs using the 3D grow region option. I'd like you to try all 3 methods, just to play with them a little bit. But ultimately, what I want you to do is to take one of them and we're going to bring it into a little program that's going to let us just do a quick render of the 3D model. We're not going to try to bring it into Maya or Cinema 4D or anything. I want you to open it in a program called Mesh Lab. Okay, sure, why not? All right, so this is Mesh Lab, and it's actually a handy program if you want to clean up, really ugly meshes, really ugly exported 3D models. It can do things like closing holes and closing gaps in models. I like it for these kind of Horos exports because it has some smoothing functions that smooth out all the ugly ridges and things that you often get. So let me import a mesh. So I'm going to go to the File menu in Mesh Lab and say Import Mesh. Sure, just why do you have to keep asking me that? So go to my desktop, and I've got my kidney, my lungs, my vertebra. Let me start with the kidney. You can just leave all of these defaults. And I'm going to select everything. So I can't really move around in here or rotate around in 3D space until I actually select everything. There's a couple of ways to select things. You can go to the filters menu. There's actually a selection option, and you can select all. Select all faces and all vertices. So everything turns pink when it's selected. Once you've done that, there's a little tool up here in the toolbar. Looks like a little 3D sphere, with a bunch of axes on it. When you select that, you can then grab the different axes and rotate things around in space. Close that. I mean, it's a little weird that I have both a kidney and a vertebrate, but I'm not going to worry about that. You can definitely see that it's retained the sort of stair-stepped appearance, from stacking up a series of slices. We can improve that a little bit using some of the smoothing options. Once again, under filters, there's a whole smoothing, fairing, and deformation submenu. And there's a whole bunch of different kinds of smoothing that use all sorts of different mathematical algorithms to do some smoothing. One that I kind of like, it just seems to work well on these models, is one called Taubman Smooth. And just choose that. It doesn't give us like a dialog. Oh yeah, that's right. Sorry, it does give us a dialog box where we can set the different parameters. If I apply that, you see it's smoothed out some of the stair stepping. I could probably play around with these settings a little bit and see if I get a little bit smoother. If I set this lambda setting a little higher, just going up in small increments, you see that it's smoothing things out a little bit. Now it may be smoothing the vertebra out a little bit too much, so it's not really accurate anymore. but it's definitely helping the kidney. It's still got that deep indentation because of, I probably had a really bad polygon in the kidney, but it's definitely smoothed it out quite a lot compared to what it was. So, you could bring in one of these models. I'm just going to go ahead and close this one. Without saving. I'm going to import a different mesh. I'm going to bring in the lungs. Let's use the defaults. Takes a little longer to load just because it's a bigger file. Once again, I can't even rotate around until I select it. So I'm going to go to Filters, Selection, select all faces and all vertices, and then my little that little tool for rotating in 3D comes up. I'm going to rotate this into interesting position. I'm going to run that same smoothing option again, the Tobin smooth. Stick with the defaults this time. Click apply. There's still a little bit of, some little ridges on here that are artifacts. Whoops. It's weird. Did that. Let me try setting that even a little higher. This may screw up the bronchi inside, but it'll do a better job of smoothing the outside of the lungs. So close that. So what I'd like you to do for today's exercise is to just generate a simple render of one of these models. And there's a render menu here in MeshLab, and there's a shader submenu under render where you can choose from some common things like just a simple Phong shader. I think might need to deselect this for that to actually be visible. So I go back to filter selection and select none. So you can see what it looks like with a Phong shader applied, which is just a fairly simple shading algorithm. There's a fun one in here. I don't think I have to have it selected. Let me just try. There's an X-ray one, which is kind of fun, especially with the lung, because it's got stuff going on inside, with those bronchi and the trachea that, viewing it this way can be kind of interesting. By the way, you can hold down Shift key to scale up and down. You can hold Command key to move around. And what I want you to do is just to basically export a simple screenshot of your render. You can do that from the file menu, just say save snapshot. And what it does is it creates a ping file. You just have to tell it what folder to put it in. All right, we'll put it on the desktop. We're going to give it a name. I'm going to call it lungs. I don't know, X-ray. You shouldn't have to change anything else. The rest, oh, you can change the background. By default, it puts this blue gradient in the background, but you could give it like a transparent alpha channel, which would allow you to select it in Photoshop and give it a transparent background. Or you could, solid white, solid black, something like that. Click Save. Just hide MeshLab temporarily. And you see on our desktop, we've got a ping file. And if I open it up in preview, you can see what that looks like. So So these are not meant to be real fancy renders. These are just, to show me that you experimented with the different region of interest, segmentation options in Horos. So you got a little over an hour to play with these. Actually do one.